we're going to continue our discussion on polynomials. And so far with polynomials, we have classified them into what they are, trinomial, binomial, quartic, stuff like that. We have also added and subtracted them. We've multiplied them when you have to do superfoil. And today we are going to do some dividing of polynomials. Dividing polynomials. It's our last operation of polynomials. Now, why would we want to divide polynomials? Well, because it's really fun. No, that's not why. When you divide polynomials, you can tell if something is a factor. Aren't we trying to factor here all the time? We're trying to find the zeros. So if you have a polynomial or anything, and if the remainder, when you divide two things, and if the remainder of those two things equals 0, then it is a factor. For example, is 9 a factor of 2,160? Yes. Okay. Is 9 a factor of that? The answer is yes. Okay. Bobby and I knew that. So maybe a couple other of you knew that. Some of you didn't. Okay. 9 has a trick. Factor means if I take 2,160, and Bobby and I did not divide this in our head, and you get 240, right? It divides into, oh, you did? Divides into it. What you do for 9s, there's a trick. If you take 2 plus 1 plus 6, and you add those numbers up, what does that equal? 9. And so if it's anything like 9 or 18, or if it's divisible by 9, after you add those numbers up, it will be divisible by 9. Think about the number 63. Is that divisible by 9? Yeah, you know that, right? What is 6 plus 3? 9. Isn't that cool? What about 72? What's 7 plus 2? 9. So anything, 5,490. Is that divisible by 9?
Yeah.
Yeah. 5 plus 4 plus 9 plus 0, 18. And that's divisible by 9. I know, right? It doesn't have to just be 9. That's why I wanted to do that one. Okay, anyways, that's not what we're doing today. That was just kind of an extra little topic for you. Extra. Okay, so what we're going to do is we're going to do two parts today. We're going to take our polynomials and we're going to do long division. Long division of polynomials. Do you remember long division in 5th grade? My son's doing it. He's actually pretty good at it. I was terrible at long division. I was like absent. Yeah, I'm going to show you just a quick example of a 5th grade long division problem. We're going to take 5 and we're going to divide that into 7,460 using long division. Now, is 5 a factor of 7,460? Yeah, because it ends in a 0 or a 5. You knew that one, right? Okay. All right, so let's remember how to do long division. So first you're going to go 5 and 7. 5 goes into 7 how many times? 1 time. 1 times 5 is 5. And then what do you do with those numbers? You subtract them, right? 7 minus 5 is 2. Do you remember this? This is a long time ago, right? Bring down the 4. When was the last time you did long division? 4th grade. 5 goes into 24 how many times? 4 times. Good. 4 times 5 is 20. Subtract, you get 4. Bring down the 6 now. 5 goes into 46 9 times. 9 times 5 is 45. Okay, subtract, you get 1. Bring down the 0. 5 goes into 10 2 times. 2 times 5 is 10. Subtract, the remainder is 0. So your answer is 1492. Oh, the year I was born. Sweet. Okay. That's a joke. I'm not that old. All right. Now, we're not going to do this, of course, because this is 4th grade math, 5th grade math, whatever. We're going to do Algebra 2 math. We're going to do something like this, the real number 1. We're going to divide x squared plus 6x plus 8 by x plus 4. Okay? We're going to take this polynomial, which is a quadratic, and we're going to divide it by this linear polynomial, x plus 4. we're going to do this by long division. Okay, I'm going to teach you 2 ways today. Long division and then a different way. That's later. Okay, so x plus 4, we're going to long divide that into x squared plus 6x plus 8. And right now you're probably super scared. Okay, no headphones, sorry. No headphones. Yeah. I know, I'd like to have some music going too, but no. Okay. All right. Okay, so now we're going to do this. This is what you want to do. You want to look at this and that only. Ignore the plus 6x plus 8. Ignore the plus 4. Just like you ignored all these numbers in here, you were just looking at the 5 and 7 to start with. That's what we're going to do here. We're going to look at the x and the x squared. And we're going to say, okay, x times what gives me x squared? X, simply x, right? I usually put that over here because that's the x column. It doesn't really matter where you put it up top, okay? So now I'm going to take that x, just like I did with the number, and I'm going to multiply it here. And when I multiply it, I have to multiply it times all the terms. So x times x is x squared. X times 4 is 4x. Everyone okay with that? So x, I just distribute it to both, and now we're going to subtract. Just like long division, just like just numbers, okay? Just on a bigger scale, polynomials. So what's going to happen is your first terms will cancel, okay? They're going to cancel for sure. The next ones, you're going to go 6x minus 4x is what? 2x, okay? And then you're going to bring down the plus 8 and do it all over again. So now you're looking at this first term here, x, and this first term here, 2x. You don't need to worry about the rest of it, okay? So what times x gives me 2x? 2. 2. So 2 will get multiplied times x, 2x. 2 will get multiplied times positive 4, so plus 8. And then you subtract, and what happens? Remainder 0. And your answer is x plus 2. When we take x plus 4, divide it into x squared plus 6x plus 8, your answer is x plus 2. Now that tells you a few things. You know what it tells you? It tells you this. It tells you that x plus 4 is a factor because the remainder was 0. It's a factor of x squared plus 6x plus 8. It's a factor of that. It also tells us that x plus 2 is also a factor. Okay? We know that if we were to simply factor this out, we would use star method. What times what's 8 adds up to 6? Guess what? 2 and 4. They are factors. The factor says that. And we also know from this that negative 2 and negative 4 are zeros of the polynomial. All of that just from dividing because we got a remainder of 0. Now if you get a different remainder, then it's not going to be a factor. Okay, none of this stuff would be true. All right, how do you feel? Pretty good? Let's do another one, number 2. I don't expect you to get this like, on the first one. We're going to have, I've got like 20 examples for you today. Not that many. Okay, x minus 5. We're going to do long division into x squared plus 2x minus 30. We're starting with the easy ones, all right? We're just doing nice, simple quadratics and linear functions and really easy ones. We're going to do some cubics and quartics coming up in a little bit. Okay, are you ready? So your job here, we're going to do long division, and your job is to first just look at the first term on the outside and the first term on the inside. And so you say, what times x gives me x squared? Just x again. Take that x and distribute it to both terms. So x times x is x squared. X times negative 5 is negative 5x. And here's where people will make their mistake. Over the years, I've found out that students are bad at subtracting. Really, it's easy to make mistakes here. We're doing 2 minus negative 5. That's tough, right? If you need your calculator, go ahead. I won't look. But 2 minus negative 5 is what? 7. But some people write 3 or -3, or they just don't do it right. So be careful when you're subtracting. That's where the mistakes happen. So 2 minus a -5 is positive 7x. Bring down the -30 now. Do it all over again. What times x is 7x? 7. Positive 7. So 7 times x is 7x. 7 times -5 is -35. And then subtract again. The 7x minus 7x will cancel out every time. Then we get -30 minus -35 is 5. Now there are 2 ways to write this answer. One way is to write x plus 7, remainder 5. Do you remember that little r? Yeah, I know, Bobby. Isn't that terrible? That's how the book writes it. That's the answer. X plus 7, remainder 5. What I like you to do is this instead. Let me show you. If I were to take 2 and divide it into 21, right? 2, well, okay, 2 goes into there how many times? 10, right? Subtract, and you get 1. Would you write 10 remainder 1? No. You would write 10 and a half, right? Wouldn't you do that? You write 10 plus 1 over 2. That's how we used to do it back in the day. So here, we would write x plus 7 plus 5 over x minus 5. That's a 5. That looks like an S. Okay? All you do is you take your remainder and put it over by whatever you're dividing by on the outside. This is the way the handbook and RAM book will have it next year. Your book right now does this, the remainder 5, R5. I don't mind if you do that, if you don't like it this way, but this is better, but it's okay. All right, let's do another one. Number 3. All right, let's do a bigger one. Are you ready for it? You so are. We're going to take x plus 2, and we're going to divide it into 3x cubed plus 9x squared plus 8x plus 4. All right. Do you ever get that feeling like, why are we doing this sometimes? Yeah, because it's so fun. All right, good. We answered that question. Okay, here we go. Nick, you love these. Don't even tell me you don't. All right, so we're going to look at the first one of each. First one out here, first one out here, in there, okay? So what times x gives me 3x cubed now? 3x squared, okay. See, I thought these were hard, but people didn't seem to think they're that hard today. I thought they were, maybe they're just lengthy, right? They just take a while. You don't like that? And make sure you show work, especially when you turn your homework in. Okay, now take the 3x squared and distribute it to both. So 3x squared times x is 3x cubed. You will get the same thing here every single time. 3x squared times 2 is 6x squared. And now subtract. So the first 2 will cancel out. You get 9x squared minus 6x squared is 3x squared. Bring down the plus 8x. And then do it again. What times x is 3x squared? That would be 3x this time. So now I'm just looking at this and this. So x times what is 3x squared is 3x. Now take that 3x and distribute it to both. 3x times x is 3x squared, and 3x times 2 is 6x. Subtract. These will cancel out. The first 2, 3x squared minus 3x squared is gone. And 8x minus 6x is 2x. Bring down the plus 4. Do it one more time. We're almost there. Now we're looking at x and 2x. So x times what is 2x? That would be 2. 2 times x is 2x. 2 times positive 2 is 4. And we get a remainder of 0. Okay? And so your answer to this problem is this right here. There it is. You're quiet. Do you hate them, or you're just like, meh, meh, don't care, meh? Yeah, okay. Number 4. This next one's a little tricky, okay? So let me show you. We're going to take 2x to the 4th plus 6x cubed plus 5x squared minus 45, and we're going to divide that by x plus 3. Now, does something seem a little off to you? Like, I mean, it's okay that a polynomial is missing something, but we can tell it's missing an x, right? There's no x there. Okay, this is what you want to do. You're going to take x plus 3, and you're going to divide it into this thing, but wherever you see any gaps, you need to fill them in with zeros, okay? So 2x to the 4th plus 6x cubed plus 5x squared, and then here we go. We're missing an x term, a linear term here. We're going to fill that in with a plus 0x. And you're like, isn't that just 0? Yes, I didn't change this at all. That's going to be like a placeholder, because I'm going to get something that's going to have an x in it. I'm going to have no one to subtract it from. I got to have an x up there, even if it's just a 0x. So do that every time you have any gaps in your polynomials, okay? All right, do you want to try it? No, I'll do this one with you, because there's actually something happens here that's really weird on this one. Okay, so here we go. You getting the hang of these a little bit? No? Did you say no? Yes, you are. No. All right. Okay, so we're just looking at the first 2 terms. The first term of the outside, the first term of the inside. So what number, or what polynomial or monomial do I multiply times x to get 2x to the 4th? 2x cubed. All right, we're going to start there. 2x cubed now distributes to the both things on the outside. So we get 2x to the 4th plus 6x cubed. See, this one's weird because what happens is everybody cancels out here. What do you do when that happens? Well, all you have to do is you just pull down the next 2 terms. And you start from there. Okay? So both of these canceled out, canceled out. You're not going to write 0x cubed. You don't need that. Okay? You're just going to pull down the next 2 terms. Now let's do it again. So what times x is 5x squared? 5x. Good. 5x. 5x times x is 5x squared. 5x times 3 is 15x. Subtract. What's 0x minus 15x? Negative 15x. See, if I didn't have that 0x there, I would have pulled down the negative 45, but that's not, those aren't like terms. I wouldn't have been able to subtract. That's why you have to fill it in with a 0. And then bring down the negative 45, and we're going to do it one more time. What times x is negative 15x? Negative 15. Take that negative 15 and distribute it to both terms. So negative 15 times x is negative 15x. And negative 15 times 3 is negative 45. And when I subtract, I get a remainder of 0 again. I like those remainder zeros. And that would be your answer right there. It doesn't happen all the time. Okay? Now I want you to try one. This is the last one of these, and then we're going to move on to the next section. It's cold again, isn't it? Yeah. Man, this room, it's like bipolar. X cubed plus 3 divided by x plus 1. I'm going to let you try this one. Okay? I can set it up for you, though. This one's missing some stuff, right? Missing a couple of things. So you're going to put x plus 1 on the outside. And on the inside, you're going to do x cubed plus 0x squared plus 0x plus 3. Okay? And I want you to try it. All right, so what times x is x cubed? That would be x squared. Did you start with x squared? I think the remainder is 2 on this one. Did you get a remainder of 2? All right, that's usually a way that you can tell if you got it right. If you got the remainder right, then the rest of it's usually right. Okay, so x squared times x is x cubed. X squared times 1 is x squared. Now be careful here when you're subtracting. I'm not kidding you. That's where you're going to make the mistakes, is subtracting. 0 minus x minus 1x squared is negative x squared. And then if you see your work, you can see where you go wrong if you got it wrong. All right, so now what times x is negative x squared? That would be a negative x. Go ahead and multiply, and you get negative x squared minus x. Subtract again. The first terms will cancel out. You get 0 minus negative 1 is positive 1. Bring down the 3. X times what is x? That's just 1. 1 times x, 1 times 1. Subtract, remainder 2. So I have no problem with you writing it x squared minus x plus 1, remainder 2. That's the way your book does. I prefer, though, x squared minus x plus 1 plus 2 over x plus 1. That's the better way to write it, the mathematical way. All right, so that's long division. So you're going to practice those. And now we have a second way to divide that's better. Well, it's easier. You're going to like it better. And it's called synthetic division. And yes, you are required to know how to do both of them. Now, synthetic. When something's synthetic, it's not as good as the original, right? Well, synthetic division doesn't work all the time. It'll work for the ones we need to do, though. It only works when you have a linear term that you're dividing by, okay? So let me show you. Synthetic division takes long division and just turns everything upside down. Everything. It's crazy. Here we go. Number, what are we on, 6, 7? What was that last one, 5? Number 6. We're going to divide 3x cubed minus 4x squared plus 2x minus 1. We're going to take that, and we're going to divide that by x minus 2. Okay. I'll show you how to do these by using synthetic division. This is what you're going to do. Synthetic division is kind of testing for zeros. So you're going to take the opposite of x minus 2. You're going to take like what you would think the 0 would be. The 0 of that would be positive 2. So you're going to take positive 2 and put that on the outside. You're going to take your division symbol, and I'm not kidding you, you're going to turn it upside down. Who made synthetic division up? I don't know, but it's pretty bomb. Okay, then you're going to take all of your coefficients, that's the numbers in front of all the variables, and you're going to write them here. 3, negative 4, 2, negative 1. Okay? All right. You're actually going to like this one better. You will. Okay, so now, here we go. This is what synthetic division does. So you're first going to start by dropping that 3 down below. Okay? Then you're going to do 3 times 2 is 6, and you write it right there. 3 times 2 is 6. You write it here. Now, I'm not telling you, everything is opposite. So now instead of subtracting, you're going to add. Negative 4 plus 6 is 2. Then do it again. 2 times this 2 out here. 2 times 2 is 4. You're going to write that there. And then you're going to add again. 2 plus 4 is 6. And then 6 times 2 is 12. And then you add and you get 11. Okay, so now you've done these numbers. What do they mean? This last number that you get is your remainder. Okay? The number next to it is going to be the constant. The number next to that is linear. And the number next to that one is quadratic. So when you go to write your answer, this whole polynomial divided by that, your answer would be 3x squared plus 2x plus 6, remainder 11. Synthetic division. You would get the same answer if you did long division instead. It's so much better, right? It's not stupid. Okay, let's try it again. Who's Donald Trump? What'd you say? Donald Trump didn't make this up. I don't even know if he knows how to do synthetic division. He probably doesn't. You're right. You don't need to know synthetic division to be the leader of our country. He probably doesn't even know what a polynomial is. He knows how to make some money, though. Yeah, you're right. All right, here we go. We're going to take x cubed minus 13x plus 12 divided by x plus 4. Now make sure you follow their directions. If they tell you to do long division, then you do those long division. If they tell you to do synthetic, you do those synthetic, okay? If they give you an option, I would choose synthetic if you can. All right, so we're going to take the opposite. We have x plus 4. We're going to put negative 4 on the outside. We're going to turn our polynomial or our division sign upside down. And then be careful. Don't start writing your numbers in yet. We have a 1x cubed and a 0x squared. You got to fill it in with zeros. Anything that's missing, you have to fill it in with a 0. We have a negative 13 and a 12. Okay? That's the setup. So it's the opposite of your factor over here. So negative 4, this is plus 4. And then over here, it's 1x cubed, 0x squared, negative 13x, and 12. So here we go. First step, drop that 1 down. Okay? That's where you're going to start. You ready? We're going to take 1 times negative 4 is negative 4. We're going to add our columns. 0 plus negative 4 is negative 4. Do it again. Negative 4 times negative 4 is 16. Negative 13 plus 16 is 3. 3 times negative 4 is negative 12. Remainder 0. Ooh. That means that x plus 4 is a factor of that polynomial. So our answer is x squared minus 4x plus 3. That's it. That's so much faster than long division. Yeah. Do you want to try one?
Yeah.
Okay. I jumped on that, didn't I? Number 8. Take 5x cubed minus 6x squared plus 4x minus 1. We're going to take that, we're going to divide it by x minus 3. It's just a different way to write it. It just means that polynomial divided by that one. Okay? You try this one. Try it, okay? All by yourself. You got this. There's the setup. Are you working hard or hardly working? It's funny. Nobody. Okay. Thank you, Irene. All right. Bring down the 5. 5 times 3 is 15. What is that, 9? 9 times 3. Oh, these are big numbers. 27.
So you always add?
Yeah.
Okay.
27. And I just always think like synthetic division is like the total opposite of long division.
Okay.
Long division I know to subtract. Synthetic I know to add. What's that, 31? 93. Whoa. 92 is our remainder. Okay, so our answer would be 5x squared plus 9x plus 31. You can say remainder 92, or you can say plus 92 over x minus 3. So that's what we divided by. Okay, now I've got 2 more, 9 and 10. Number 9. Synthetic division is going to help us to completely factor polynomials, because that's what we're really trying to do. We're trying to factor polynomials. We're trying to find the zeros of them. So we're going to completely factor x cubed minus 2x squared minus 5x plus 6. Okay, we can't use star method. We can't use difference of 2 perfect cubes. We can't use anything on this. There's no trick to factoring that. We're going to completely factor this given that x plus 2 is a factor. All right. This is a 3rd degree polynomial, okay? This 3rd degree polynomial is going to factor into 3 factors because it has 3 zeros. And we're given one of the factors and we have to find the other 2. So this is what we're going to do. We're going to take x plus 2 and we're going to divide it into here to get rid of, that factor and get it down to something that's manageable. So let's do synthetic division because we like that better. So we're going to take negative 2. This is x plus 2, so we take negative 2 on the outside. And we do 1, negative 2, negative 5, and 6. And you're going to get so good at these, you're going to go super fast. You're going to bring down the 1. 1 times negative 2 is negative 2. Add negative 4. Negative 4 times negative 2 is 8. Add 3. 3 times negative 2 is negative 6. Remainder 0. Now, if you don't get a remainder 0, then you did something wrong, okay? So what we end up with is x squared minus 4x plus 3. And guess what? You know how to factor that. That's just simple star method, right? 3 goes up top, negative 4 on the bottom, 1 and 1. Two numbers that multiply to give us 3 and add up to negative 4 would be negative 3 and negative 1. So this polynomial factors as x minus 3, x minus 1, but then don't forget, go back up here and put the one that they give you next to it. This is completely factored. And then we could even say what the zeros are. The zeros are 3, 1, and negative 2. We could even graph that if we wanted to, but we don't. Okay, and then finally, the last one, number 10. Whew. All right, we can use synthetic division to evaluate a polynomial. So let's say that we have a polynomial p of x, okay? And p of x is equal to x to the 4th minus 5x squared plus 4x plus 12. All right? And let's say that I want to find out what p of negative 4 is. I want to evaluate the polynomial when x is negative 4. You're like, cool. I'm just going to take negative 4. I'm going to plug it into my calculator. And oh, no, you can't have a calculator on this one. I'm sorry. Right? How are you going to do that? Well, I'll tell you. What you're going to do is you're going to use synthetic division, and p of negative 4 is going to be the remainder. You don't care about any of the other stuff. It's just the remainder. That's what p of negative 4 is. Like when you did like p of 2 and 2 was a factor, your remainder was 0. So if I plug 2 into my polynomial, I will get 0. If I plug negative 4 into here, it's going to be my remainder. So let's do it that way. We're going to take negative 4. Don't take the opposite. This isn't a factor. It's just negative 4. And we're going to do long division with this. Okay? So I have 1x to the 4th, 0x cubed. Be careful. That's where people will make mistakes too. Negative 5, 4, and 12. These numbers are going to get pretty big, but they're manageable. I wouldn't think that you'd want to take negative 4 and raise that to the 4th power in your head, right? That would be pretty hard to do. All right, so here we go. We're going to bring down the 1. 1 times negative 4 is negative 4. Add 0 and negative 4, and you get negative 4. Negative 4 times negative 4 is 16. Add those, what do you get, 11? 11 times negative 4 is negative 44. Add those, you get negative 40. Negative 40 times negative 4 is what, 160. Add those, 172. That's your answer. P of negative 4 is 172. If I were to take negative 4, and I can show you on my calculator, if I take negative 4, oh, I did it earlier, and I plug it in, negative 4 to the 4th minus 5 times negative 4 squared, you do the whole thing, you will get 172. Isn't that so cool? No? So cool. All right. Same thing. If you were to evaluate P of 2, okay? Do synthetic division, and whatever the remainder is, that's going to be your answer. All right? You want to try that one? No? You're done? You believe me? Okay.